So welcome everyone. Um, Welcome everyone to the Astrocoding workshop, day 4 documentation and debugging. It's also the day 4 documentation and debugging. Um, First of all, we'll first go over debugging and then we'll come to documentation. To do that, I think I have to switch to VS Code. Okay, you can see this, right? Uh, so yeah, um, I imported NumPy and Matplotlib just for the sake of it. Let's run this. Yeah. So in the previous 3 days of workshop, you have written some amount of code, and in that some amount of code, I'm sure you have come across a lot of errors. So in this part of the lecture, we'll go over some of the common errors that you will face and how you can deal with them. So here are some of the basic errors that you will encounter. I'll just go over them one by one. Attribute error is when you have so let's define a class, say animal, and then we initialize it. Let's say the animal has a name, and we assign the attribute name. So now we have defined this class. Now let's make an object of this class. We have to give it some name. Uh, what name do we? Let's say dog. And then you run this code, works fine. Now you want to look at the attributes of animal. One attribute that we know is name. So if you go and run that, you will get the name of the animal. But if you try to look up an attribute that we have not defined, say age of the animal, you will get an error. Yes, this is the attribute error. You're trying to access an attribute of an object which is not there. That is an attribute error. Next, we have index error, which is basically if you have let's define a list and say we have 3 elements in the list. Index error is basically if you try to access. So if you try to access the second element, the third element of the list, you do it like this, and you will get the second element. But if you try and access an element that is not there, so let's say you want to access the third element, so the fourth element. So we clearly see that there is no fourth element. So if you try and access that, you will get an index error. That is an index error. Then we have key error. Key error is when you define a dictionary. Dictionary. We have something like this. We run it, and then we want to access the values of this dictionary. Um, so you put in a key, and then you get the value corresponding to the key. And if you try and access the value of a key that doesn't exist, you will get a key error. Whatever key that you're trying to access is not there in the dictionary. That is a key error, and syntax error is, I'm sure you know what syntax error is. Say this. You're trying to print something, but there is a spelling mistake. That is, uh, that's a syntax error or name error. What is a syntax error? Mm, okay. Say you're trying to define a function, but you don't put the semicolon. I think this is supposed to give you an syntax error. Return none. Yeah, syntax error because you did not follow the proper syntax. And then we go to indentation error. This is again, I'm sure you kind of can guess what it is. This will give you a yes. I'm sure this will give a syntax error. Indentation error. No. What will give an indentation error? Let me think. Uh, Let me just check.
It will be just a mismatch in the indentation. So like you
What?
place one tab. Yeah, it will be a mismatch in the indentation. So you define a function, then give one tab, write
Yeah.
something. Then in the next line, you write another two tabs. That would be indentation.
So something like, oh, yeah, I think I forgot the brackets. Now I think it shouldn't do an indentation error. Yeah, there we go. So that is how you deal with an indentation error. You make sure everything is properly indented. And then comes value error. Value error is, so let's say you want to, so say you have a string. In the string you have number, and you want to convert the type of this number from a string to an integer. How you do that is you, you do it like this, and then when you print a, sorry, and then when you print the type of a, to redefine it, now we should get it as an integer. So these are some of the more common errors that you will face. Uh, and said that, so you will come across errors that are not listed here, and you might or might not know how to deal with them. But uh, the first thing that you should do is read the error messages. So if you read the error message, you will know what kind of an error it is and at which line is the error showing up, and yeah, and a description of that error. So the first step to deal with an error is to read the error messages. Now we'll talk about something called as talk about things that are called as exceptions. Exceptions are basically errors that you will encounter when the code is being executed. So something like a syntax error or an indentation error, the code is not being executed. You get the error before the code is executed because the indentation is not correct or the syntax is not correct, but Executions are when all the syntax is correct and the code is being executed, and then in the middle somewhere it crashes because there was an error. Um, so how do you deal with exception errors like that? Is something called as you use try and except. Basically, let's say you have this block of code which tries to read your mind, and so you want them to choose a number. If you run this, it will ask you to choose a number. So what you want is for the user to input a number, and then let's say a number, and then it will give you was to the number you chose, and that's it. But the user is not constrained to give you a number. The user can also give you a string as an input, but you don't want that. So how do you deal with that? So first you will try this block of code, and you assume that the user inputs a number. And okay, so let's just go ahead and run this again. So let's say if you input a string hello, and since hello is a string, the int function that you have here will give you an error because you are not inputting a string which has a number but which has letters. So it will give you an error, and so when that error comes, uh, the code will go into this except. So if we go ahead and enter this, uh, uh, we will get an error and the code will go to accept, and then it will go ahead and run whatever is there in the accept block. So if we go ahead and enter this, we expect to get the this string as the output. Yes, that is not a number, which is what we expect. So that is how you use try and accept. Finally is basically, so if your code runs well and fine, uh, the try block runs, and then it will go to finally. If you encounter an error, the code will go into accept and runs whatever is there in accept, and then it will again go to finally. So whatever happens, so either the try works or accept works. Whatever happens, you at the end you will also uh, run whatever is there in finally. Okay. Sometimes you might also be in situations where you want to create an error yourselves. So even though the code will not give you an error, you want to raise the error yourself. So an example for that might be you're defining a function, um, say age, and you have a number. Uh, and then let's say try. Um, let's say this function returns your age. You are, this is an string. You are this many years old. Yeah. So since this is just a number, anybody can enter whatever number they want. So, so technically, you can just enter age 999 or something. But you know nobody is that old. So you might want to raise an error when somebody inputs an unreasonable age. So you do that by Again, you do it using try and accept. We first define try like we used to. This, and you will have an accept. Um, say, uh, how do you do this? Oh no, you don't use. Okay, you do it using conditional statement. So if num is, say, what is something less than 100, then you want your function to work fine. You are this many years old, but if not, then somebody has entered an unreasonable age, then you want to raise an error. You do it by doing this. Think yeah, you raise. What kind of error do you raise? I think value error. Um, Please enter real age. So now when you run this, you will get a value error. Please enter a real age. So without this, without this, without, if you hadn't raised the value error and had instead just did this, the code itself has no error, and it's since it's a number, the code will work just fine. Yeah, and it will give you are 999 years old. But yeah, you can create your own errors depending on your code. Now that we have dealt with our errors in some capacity, as you progress in your coding journey, you will have situations where you don't want to manually debug everything, and that is when you can take help of debugging tools. So, so every IDE mostly has a debugging tool, and so in this section we will go over how to use the VS Code debugging tool to debug piece of buggy code. Uh, so this block of code, it's a pretty obvious bug. Maybe you already notice it, but we'll just use this to go over how we can use the debugging tool. So on the left side of your VS Code, you will see this icon, run and debug. So you click on that, it will show you a run and debug. Yeah. So then you click on that and you select a Python debugger because you're writing in Python. And it will start. Also, before that, if you hover over your lines of code, you will see all these red circles. So these are called breakpoints. So these are basically, so when your debugging tool works, it will go over each line of your code, and then whenever it hits an error, it will stop. But you can also like customize where it will stop. So if you can choose where you want to, let me just close it. Yeah, you can choose where you want your debugging tool to stop so that you can check your code. So let's say we have a breakpoint here, and then here, let's say, and then here. Sure. So if we go ahead and run this code, we should get an error. We don't get a plot like we're supposed to. So let's debug this using the debugging tool. So if you are working in a notebook, so beside this execute cell option, you have an arrow, and if you click on that, you have this option debug cell. Uh, so so click on that, and it will start debugging your code. And yeah, you do see that the debugger has stopped at your breakpoint. This is the first breakpoint, and you also have this. What do you call it? You also have this on the top. You have some icons. So so if you hover over them, you see continue. It will just continue debugging, and you also have this option called step over. With step over, you can go over like line by line of your code. So it went to the next line. Similarly, you can go to the next line. So also notice that it jumps over function. So it doesn't go into the function, it just jumps over the function. And so this is how you use the step over. If you want, let's redo this. So this option will restart the debugger, and it will again stop at our breakpoint. And yeah, we go to the next line, and next line, and next line. Yeah, so this is where we expect the error to be. We expect some error happening in this when we're calling this function. So to we can also go into the function. So remember how the debugger just went over the function and not into the function. We can also now just go into the function by clicking this one. This is called step into. It will step into the function so that we can go over each line in the function and see where the error is happening. And also you have something called as debug console. So this will show when you are in whenever you are in the debugging mode. First line, there is nothing wrong. And we go over, and then we go over, and at the end when you're returning x and y, since it was a since we okay, it's not there, but let's just check the shapes of x and y. You can do that by just typing x dot shape and then y dot shape. So you do see that the shapes of x and y are both different, and that is obviously because of this line of code. So now that you have identified the error, you can restart our debugger, and yeah, again we go to the same line, we step into it. Now let's check our x dot shape again and y dot shape. Now both of the shapes are same, and we shouldn't have any problem. So we have possibly fixed our bug. So now it's time to step out of the function. We do it by using this button, step out, and then we move on to the next line. And yeah, hopefully we should not have any problem. And yeah, it works fine. We successfully debugged our code, and that is basically how you use the debugging tool. Of course, this was a very small example, but in the coding session, hopefully we'll go over some more examples so that you will get your practice with debugging using VS Code. That is pretty much all I have about debugging today. Now we will move on to the more boring part, which is documentation. Let me just change the tab. Yeah, now you should see the presentation. Day for documentation and debugging. Yeah, before we go over what is documentation and yeah, okay, so let's just go over what is documentation. Documentation is basically um, mm, so you basically explain the code so that whoever is using your code, which includes you, will understand about the code. So it's basically a description of the code. And why do you need to document your code? You need to document your code because it's just, yeah, this is a quote by this guy. I think code is more often read than written. More people will read a piece of code than the number of people who write that code. So it is important that whoever is reading the code understands what is written. And to make that process easier, we document our code. Um, Also, I'm sure you know what comments are, I think. So it is also important to comment your code because the code tells you how and comments tell you why. Comments also serve a similar purpose as documentation in that they explain about the code, but comments are usually shorter. We'll go over the difference. But yeah, and moreover, why do you want to document your code? We went over why you need to document your code because you need to make it accessible for everyone else who might read your code and want to use your code, but you yourself want to also document your code because you want other people to use your code. So let's say you work on a project and then you write a big piece of code and some other person also wants to is also doing the same project and they might want to use your code. But if your documentation is not good enough, people will just not use it because they don't understand what's going on in your code. So that is why you need to document your code. And also, I've already mentioned two things that are not the same: documenting your code, and then commenting your code. Let's just look at what the difference is between them. So comments are mainly intended for other developers of your project. So if you have more than one people working on a project, um, comments will help the other developers understand what is going on and what they need to do to understand the purpose and design of your code. And then documentation is mainly intended for whoever will use your code. So they're not adding to the code; they're just using the code. And so documentation is usually more elaborate because they are not developers themselves, so they need more explanation. Uh, so now that we have established the difference between commenting and documenting, let's start with commenting your code. So the first thing about commenting code is where, when, and how do you comment your code. I accidentally left this slide unfinished, but this unfinished slide will do a good job in explaining the where, when, and how. So these are these are so as this point says, the above points describe how comments can be used in code. And we also have comments here, which I write about all the points in detail and explain with examples when possible. So this is basically I was planning what to do with the slide. And that is the first point. And then the second point, code description, is whatever I'm doing here. The above points describe how comments can be used in code. So whenever you're writing code, you can write a comment that describes what's going on in the code. And then the third point, algorithm description. If you are using an algorithm in your code, it will be helpful if you comment what algorithm you're using. And then finally, tagging, which is basically if you have something that you need to fix in your code, or if you want to write what you need to do in your code, you can just write a comment that says whatever you need to do. So this is in a nutshell the where, when, and how you can use your comments. And then now that you know where you need to comment and how you need to comment, these are some of the rules that you need to keep in mind when commenting. First of all, keep the comments close to the code they're describing. So don't put your code in the first line and then the comment in the at the end of the file. Keep the comments as close to the code as possible, and then avoid redundancies. So let's say if you're printing something, you don't need to comment that this function prints the string because everybody knows it. So make sure that there are no redundancies, and also make sure that there is no complex formatting. Just write lines and don't put too much effort into formatting. And then at the end, design the code to comment itself. This is so you are not exactly going to comment in the sense that you are not going to put a hash and write comments like this, but the way you write your code will be such a way that it is already easily accessible to the readers. And how do you do that? Um, One second. One way you can do that is using type hinting. We'll go over these following questions and understand what type hinting is. So first of all, we'll go over what are types and how do you check for types. And then we'll come to what is type hinting and why do you do it? How does it help? And then what does type hinting not do? So to answer these questions, let me just switch to VS Code again. VS Code. And yeah, there we go. So we are in VS Code again. So yeah, what are types, right? So everything in Python is basically an object, and type is basically type tells you which class the object belongs to. So type is basically a classification that will tell you what class an object is. And you can check the type of an object by just using this function. We've already done this before. Basically, if you have a list and you want to check the type of the list, you can do it like this. It will give you a list. Let's say you have an integer is equal to 5, and then you can check the type of a. It will give you an integer. You can also check the what else. Say let's say you have an umpire array. Just define an array. Again, the same array. Now it's an umpire array. So when you check the type of my array, it will tell you that it's an umpire array. So whenever you're writing code, either you're defining a variable or you're defining a function, you're defining a class, you can state what kind of an object the variable is supposed to be, or what kind of an object the arguments to the function are supposed to be, and what kind of an object does the function return. This is this is what type hinting is. So if you look at this function, it will give you it will do a division for you. You will give it two numbers and it will give you the quotient of the division. So as we can see, you hint the type of the arguments. So let's say the first argument A, you're hinting that A is supposed to be an integer. And then the second argument B, you're hinting that B is supposed to be an integer. And then at the end, what the function returns, you show it like this. You put a minus sign and then uh, a greater than sign, yeah, greater than sign and then a float. So this basically tells that whatever the function returns, it will be a float. And yeah, yeah, as we can see, a by b will result in a float. We can check this by doing, say, 8 comma 2, and then we want to check the type this function of whatever is returned, and then you do get a float. And similarly, for if you're defining a class, you you again can hint what the type of the argument is going to be. And also when you're defining an object, you can hint uh, what class the object belongs to by just writing the class followed by a semicolon. Yeah, and this is how you do type hinting. However, types are not deal breakers. Your code will still run if you yourself do not follow the type hints. So let's say you have this function. Uh, it says hello, and you need to pass it an argument. Argument is name, and it will return hello, whatever the name is. So when you're defining function, you're defining it. So you expect it to take strings, and it will give you hello and whatever that string is. But you can also just give it a number. Um, I just comment this. And even though the argument 12 is not a string as the type hint suggests, it will still run because there is nothing wrong with the code, and it will give you hello 12. So although type hints can help you like help you know what the types of arguments and whatever is returned is, they will not they will not stop if the type hints are not followed. So then how do you make sure the type hints are followed? You do it by something called as type checking. So we have packages that will make sure that whatever is being passed to the functions follow the type hints. So uh, so if you're working on a notebook, you can run this line. You will basically install two packages, mypy and nbqa. And if you're just working on a Python file, you don't need to install the nbqa. But basically, you install these two packages, and it's taking its time. Yeah, we have these packages. And now we go ahead and save this file, and we open our terminal, go to the terminal, and we type this command nbqa mypy. And then to check the type and to proceed with type checking, you input which file you need to be type checked, and then you run this, and after it runs, it's still running, I guess. Yeah. So when it runs, it will give you all these errors. These are errors when the type hints are not being followed. So you have 12 errors, so meaning you have 12 instances in your code where you're not following your type hints. So this will help in debugging your code, and this will help you make sure that you're following the type hints. And let's just make sure that we correct all these. Okay. So ignore all the errors in the previous code, but the one that we're after is uh, which is the one that we're after. Say hello. Yeah, this is the one we're after. Argument one to say hello has incompatible type int expected string. So this will help you debug your code. And once we rectify this error, and once you save it, you again run the same command bqa in my pipe and test 3. Now if we again run this code, this error will not show up because we have corrected it. Yeah, you see one less error, and that is the error that we corrected for. So this is how you can use type checking to make sure that all the arguments are the kind of objects they need to be. And so this is how you can use type hinting and type checking to make sure that your code has no errors, and that it's more accessible to the readers. And let me switch to the presentation again. So that was all about type hinting and comments in general. And now that we have uh, talked about comments, we can move on to documentation. And although I say documentation, you see I've written doc strings. That is because, uh, well, before that, let me just remind you that everything in Python is an object. And doc strings are like the fundamental blocks of documentation. Whatever you are documenting, you do it by constructing doc strings. And so since everything in Python is an object, every object will have a documentation. And that means every object will have an attribute that stores the doc string, which describes the object. So let me change to VS Code again. Yes, doc strings are fundamental, the foundation of documentation, and whatever documentation you are going to do, you will be doing it by using doc strings. So let's just take an object. Let's say list. Let's just define a list. And we already defined. So since this is supposed to be an object, this is clearly an object. This is clearly an object. You can check it by using the type. So this is a list. Now, if you want a documentation of the list object, you can just do it using the help command. Uh, so you put in the object you want, and this will give you the documentation for a list. Smaller. Yeah. So all of this, the whole thing is a doc string, right from help on the list object to the end. And this is the documentation for list object. So in the documentation, you see how the list is, how the class list is defined, and what are the methods associated with a list. Here you see something that you often use, append. How append is defined: append an object to the end of the list. And then what clear does: remove all items from list. And what insert does: and for every function you also see what are the arguments that are supposed to be passed. So like this, you can access the documentation of any object that you want. Let's say again an integer, and then you want to look at the documentation for an integer. And here you see the docstring, which contains the documentation for an integer. Here we see the class integer being defined, and convert a number or string to an integer or return 0 if no arguments are given. And so like this, you can access the documentation of any object that is built in Python, any built-in object. And you can also look at where this docstring is being stored at. So it is, so let's say for my list, you have an attribute called doc. If you go ahead and print this, you see, wait a minute. Oh, okay. Instead of this, yeah. So you can also look at where the docstring that you are seeing here is stored by using this command dir markdown. So dir my list. Go ahead and print that. Here you're supposed to see, yeah, here you see this attribute doc. Uh, this is where the doc string is stored. Now that you know where the doc string is stored, when you create classes of your own, you can you can assign whatever doc string that you want to that attribute. So let's say self dot doc. So this is the attribute to which you want to define the documentation. So say this is an animal. So now that you have defined this attribute to be this, go ahead and run that, and yeah, you can create an object animal. Oh yeah, instead of this, let's say before we do that, let's just make this pass. And once you create an object of the class animal, you can individually assign a documentation to this object. So instead of having this documentation apply to every animal object, you can just have the documentation assigned to only this object. So if you go ahead and do help animal, you will you will get the docstring that you define. This is an animal. But if you go ahead and define another animal, say 4, this is also an instant of the animal class. And then if you want to look at the documentation of animal 4, uh, what's I think, let me just rerun this. Now it will, yeah, so now it won't give you the documentation that you have defined here, because you just did it for only this object, not the whole class. um, yeah, so you see that there is no documentation particularly, it's just the initializer. And so if you want to have the documentation for every object of the animal class, you do it when you're defining the class. You do it by self dot doc, and then you can just write this. So now every object of an animal class will have this documentation, this docstring as its documentation. So if we go ahead and run this again, we get that this is an animal. So that is the thing, that is the docstring that we have defined. And also, you don't need to, instead of setting the attribute directly, you can just write your docstring under, right under the, right under your definite class definition or function definition. So like this. So let's say you're creating a class called book, and then instead of setting self dot doc is equal to this is a book, you can just use triple quotation, triple double quotation marks, and in between you can write whatever you want to write, and this will be your documentation for book. So when we create an object called book of, of this class, and then we call help, let me just run this. And if you call for help, yeah, you will get your, this is a book line, and you also get whatever you were getting before you wrote this. So when you are directly setting the attribute to a doc string, you are losing everything else. But if you're doing it like this, you still have everything else, and you also have the docs, and then you also have the line that you wanted. So that is how uh, doc strings are internally stored in Python for all the built-in objects, and that is how you can write documentation for the classes and functions that you are defining. And we will also go over what kind of doc, the types of doc strings. So the first type of docstring is the class docstrings, which is what we did up until now, which is basically whenever you're defining a class, under that you write a docstring like this, and then if you're defining a function of that class, you also write a docstring under that function, which describes what the function does. So this is about class docstrings. So most of the time, so as you're starting out, these are the docstrings that you'll be using the most. But when you get to a stage where you are writing whole packages of code, and or else single executable files, which are scripts, you will also want to have other kinds of docstrings in the files that, instead of describing what an individual class is or what an individual function does, um, the package docstrings, module docstrings, and script docstrings, they will describe they will describe what the package does and what the package contains, or if it's a module docstring, what the module is about and what are the functions in the module, and then if it's a script docstring, what the script does. So you write so you write all that explanation at the top of your files, and that is another type of docstring. But mostly we'll be dealing with these kind of docstrings for now. Um, Before we go ahead and try to make actual documentation of an example project, let's look at the different kinds of docstring formats. So we'll be going over two formats, and although there are other formats as well, these are like I advise you guys use one of these two formats. So first, let's just define a function called multiplication. It takes it takes two arguments, a and b. A is an integer, b is an integer, and it returns a float, a into b, right? And so now we want to document this function. So the docstring for that if we are using the Google Doc strings format, will look something like this. In the first line, you're going to write what the function does. It's just a one-line summary, takes in two numbers and returns the product of the two numbers. And then you're going to leave out a line, and then you're going to specify what are the arguments that are being passed down to the function. So first of all, first argument, it's an integer. You denote it in brackets, and then a description of the argument. So it's the first number in the product, and then similarly you have b second number in the product, which is also an integer, and then you leave out another line, and then you write returns what the function returns. It returns a float and a description of what it returns, the product of a and b as a float type object. So this is the Google doc string, and then you also have another format which is numpy and scipy doc string. It obviously does the same job, which is explaining the arguments and what is returned by the function, but it's a slightly different format. You again have I forgot to change this. You again write the same thing, takes in two numbers and returns the product of two numbers. So one line description of the function, and then the parameters a and b. A is an integer, you denote it like this time, and b is an integer, and the same description. And again, you leave a line out, and then you write returns, and then you have this line of dashes, and then you have it returns a float, which is product of a and b. So these are the two formats. These are two formats of doc strings. As I mentioned, there are also other formats such as epi text, restructured text, but those formats are slightly less intuitive. Uh, yeah, so I advise you use these two formats. You can use any of the formats, of course, but make sure that you are consistent with the formats throughout your project. So if you're using a format, use it throughout your project. So now we will try to do something interesting. We will try and make some documentation. So before we do that, let me let's share something else. So now you see this. If we go over to matplotlib's documentation, you look at something like this. I'm sure you have looked at this when you were working in the coding session of the first 3 days, and you see something like this, and then you go to another tab, and then it says scipy documentation, and yeah, so I'm sure you notice the similarities between these two, although these are documentations for different packages. You notice some similarities, and then to address the similarities, if you go down to the end of the page, you see a line here that says created using Sphinx. And then you go over to scipy documentation, and then you again see this line that says created using Sphinx. So the thing is, nobody makes these documentation web pages from scratch. So there are tools out there that will make the web pages for you. And so once you have documented your code properly, you can use these tools to make web pages like these for you, which is what exactly what we'll try and do. So if you want to code along, you can download the folder that I've shared on Discord. It's there in the notes and resources channel. You can go ahead and unzip that. You will have a folder called calculate, and let's just look at what is there in the folder. So there is an init.py file. For now, it doesn't have to contain anything because it's just one file, and yeah, you don't need to worry about the init.py file for now. But the main code is in the calculate.py. So this code has four functions which will perform basic operations for you: add, subtract, and multiply and divide. And let's say this is your project. You make this project and now you document all the functions and the module itself. Now you want to make a web page for the documentation. And of course, we are going to do it using the same thing. We are going to use Sphinx to do that. Uh, to get started, let's go into the directory. Let's just say cd day 4. Yeah, so we are in day 4, and now let's just go to the calculate directory. Now that we are here, yeah, now that we are here, we can start with Sphinx. So what you'll do is you're going to go ahead and install Sphinx first, and it is going to install the package. Since I already have it installed, it just says requirement already satisfied. Yeah, once you've done that, you will also need a few additional packages. So you can go ahead and run this line, and also this. So you're going to go ahead and install these two packages. So what this package, so the first package is because the format that we are going to use. So if you look at the documentation, we have used the numpy doc strings. So the format that we are using, Sphinx by default doesn't know how to deal with this format. So we are going to install this package, which will help Sphinx with the format that we have, and then also PyData Sphinx thing. If you go back to our documentation of mat.lib, let's say, at the end, you see this built with PyData Sphinx theme. So it is basically the theme that you're going to use for your web page. And so we are going to go ahead and install that as well so that we can use the theme. We are going to run this. It will install the packages for us. Again, since I already have everything installed, it will just give me a requirement already satisfied. Um, oh, yeah, and then now, now we have all the packages that we need installed, and now you're going to go ahead and create a directory called docs. Why do we do that? Why do we do this? Is because go ahead to the presentation. So when you want to document your projects, documents are usually structured like this. So you're going to have the main directory, whatever your project is. And in the directory, you're going to have a subdirectory called project code. This is where all your code lives in. And then along with that, you will have a docs directory. This is where all the documentation is going to be. And then you're also going to have a README file, which will have a description about your project. And then if your work, and then if you want others to contribute to your project as well, you might have a how to contribute file. And then you can also have some examples which will get others started using your project. So this is how we want to structure our project, which is what we did by creating a docs directory. And in the docs, this is what you will typically expect. You are going to have tutorials, and you are going to have how to guides, and you are going to have references. And then, yeah, you're going to have some explanations. But yeah, this is why we create the docs folder where we created. And let's get back to the get back to our implementation journey. Now that we have created this directory, we go ahead and go into the directory. Now we are in the docs directory, and this is where Sphinx will start doing its thing. We'll type this command, Sphinx quick start, and you go ahead and run that. It is going to ask you a question whether you want these two source and build directories separately or not. You can just go ahead and say no, it doesn't matter for now. And then the project name, what do you want your project to be called? Say calculate, and the author name is my name. Project release, don't worry too much about these numbers. You can just say 1.0.0. And the English and the project language, by default it is English, so you can just leave it as it is. And now if you go ahead and look in the docs folder, which was previously empty, now contains all these files. So these are all the files that Sphinx generated just now. And in these files you see a file called conf.py. This is a configuration file. So in this file you're going to specify information that Sphinx will use to make the documentation. And so since we want Sphinx to make the documentation web page, and in the web page we want the documentation for our calculate.py, we need to give it the path to the let me just uh, uh, yeah, let me just check 1 minute. Yeah, we go ahead and import this package called sys. Then we're going to insert. So we need to insert the path to our calculate.py. And since our calculate.py lies just above the docs, so just one step above our current directory, which is along with docs, we can just do this, and this is a relative path to our calculate.py. So once we have that, we have our path, and we also need to specify what the main page of our documentation is going to be. We do it by using the root doc variable, and we're going to set it to index. So the index.rst file that you see here, it's a restructured text file, uh, which is basically a bit more complicated than text file. But basically, this is going to be our main page for our documentation. And below that, you see an extension list. In this list, we specify the extension that Sphinx needs to be using to create documentation. So let's go ahead and specify which extension it needs. So this extension will allow Sphinx to automatically create the documentation from our doc strings that we have created. And then this we're going to change it to our desired theme, which is file data strings theme. And this is I think this is it. So now you have your configuration file ready. Once you have the configuration file ready, you go ahead to the terminal. Now you type make HTML. Go ahead and enter that. It will. Okay, we have an error. Theme error. Okay, I think I made a mistake in the name. Let me just check what the theme is. Uh, okay, so it's an underscore. Let me change it to underscore, and now it should be fine. Make HTML again. And yeah, Sphinx did its thing, and we it says that the HTML pages are in build/HTML. So we see a directory called build in the docs. Look into that, and there is another directory HTML. You go into that, and then you see this file called index.html. So this is our web page for documentation. You can go ahead and open that HTML file. Let me just go into that. Where is it? CD. Oh, okay. HTML. Yeah, just go there, and then you can just open it using start index HTML, and it has now opened the web page. Let me just show it to you. So this is what Sphinx created. If you look at this, you have the calculate documentation, you have the title, you have the web page just like how matplotlib and scipy had. But there is one problem, and that is there is no documentation. And yeah, this is because we we don't have a restructured text file for our calculate Python file. So for our web page to have our documentation, we go back to our VS Code, You go into the docs file, and at the same level where you have index.rst, you're going to create another file that is called calculate.rst. So in this calculate.rst file, you're going to specify what the web page is going to look like for calculate. So let's say you define the label of web page like this. It's a lot of syntax, but that is how you do it. And here you input the title of the web page, and then a little more description of the package, say functions to perform calculations. And then here is your most important block of text that you are going to write. You're going to put two full stops and then a space. And then you're going to type auto module. This will allow Sphinx to automatically create docs for you based on your doc strings. And then you're going to say what is the Python file. It needs to, the Sphinx needs to go and look for doc strings, and then you do enter. So make sure the whatever you're writing here is what the Python file is named as. So since we have calculate.py, you write the same thing, and then you enter, and also notice the indentation. Make sure the indentation, make sure there is a tab, and then you are going to write colon members colon. So what this tells is it's going to tell Sphinx to create documentation for all the members in the calculate Python file, which is py calculate.rst file. So we just write here at the same level of indentation. Notice that here you see a similar format to what we did before. Here is a title and here is a small description. And this TOC tree means table of contents. TOC stands for table of contents. Ignore this for now, but basically you're going to put your calculate.rst file here. And so this will make it so that your index, so your main web page will link to another web page, and that web page is going to have your documentation for your Python file. So now you can go ahead and save that, save your index file, and then you run your command again. Let's just you go back. Yeah. Let's go back to our docs directory. Now we're in docs directory, and we're going to type this command again, make HTML. Now that we have made all the changes to index.rst to include the documentation of the calculate Python file, we can run this command again. And yes, and now we should have our web page updated. Let's go ahead and open our web page again. Some build HTML and then index.html. So let's open our web page again. I'm going to switch. Yes. Now you see the web page has updated itself, and you have the contents, and now you have this thing, calculate functions. If you go ahead and click that, it is going to take you to this page. So this is whatever you're seeing in this web page is the result of whatever we wrote in the calculate.rst file. So we have our documentation for all of our functions. You see the title that we wrote in our RST file, and then the description that we wrote, functions to perform calculations. And then this line, if you remember, was there in the calculate.py file. This was at the top of the file, the doc string, and then this module contains the following functions, and then you have documentation for each of the function individually. So the add function, the arguments and the types of the arguments, and whatever the function is going to return, the parameters and their description, and the type of the return, and a description of whatever the function is returning. And so like that, you have a nice web page for your documentation. And obviously, it's not as thorough as SciPy documentation or Matplotlib documentation, because we just have one Python file with 4 functions. But this is a start. Everything works in this. You can go ahead and search for a function if you want. Will give you search results. And yeah, you can look at the search results. Yeah, basically that's how you create these web pages for your project. You also see our version 1.0.0 that we wrote. And then at the end, we have the copyright created using Sphinx 9.0.4, just like we saw in Matplotlib and SciPy, also built with PyData Sphinx theme. So that is basically how you document your code. And with that, I think we are done. So in summary, we have learned how to debug our code using some of the debugging tools in VS Code. And then also after that, we looked at how to document our code, using doc strings, and then at the end, how to make documentation web pages using strings. So that is all I have for you today. That's it. Yeah. Yeah. So, yeah. So hopefully in today's coding session, you will get to make a project of your own and hopefully make the documentation for as well. So yeah, do attend the coding session.